What's up, curious monsters, and welcome to the lab. I'm Teacher Jackie. Oh, wait. 1 second. Anyway, today we're gonna make our own wire spinner. This is something called a homopolar motor. We'll learn how to make it and how it works. Before we get started, don't forget to like this video and subscribe to the channel so you always find cool new videos and boredom-busting shenanigans. If you like and subscribe, more videos like this will pop up for you. And it'll pop up for other kids too. More fun for everyone. Alright, for this one, we're going to need a battery, some copper wire, and a really strong magnet. For the battery, there are many different kinds that you can use, but the most common ones that we can find are the ones like this, the ones with the bump on top. As for the magnet, it has to be really strong. Otherwise, the spinner won't work. That means the magnets from the fridge probably won't cut it. The kind I'm using is called a neodymium magnet. It's one of the strongest kinds of magnets in the world. Then we'll also need something to bend and cut the wire. That'll be wire cutters or pliers. Because we'll be using those things and because we'll be dealing with electricity, you're going to need the help of mom, dad, or anyone else who's older to help you with this experiment. As a side note for moms and dads, make sure the wire that you're using is not insulated. Otherwise, it won't work. Ironically, the wire called magnet wire is insulated. So even if it looks like a normal copper wire, it's not going to work. To know if the wire you're using will work, press it on the top and the bottom of the battery. If it gets warm, you're golden, because that means it's conducting electricity. Okay, if you've got those things, grab them and let's go. Let's make a basic design first. Okay, step 1. Here's the hard part. Okay, here we go. Take your battery and put it on the magnet. Ah! Just kidding, it's not gonna explode. Next, we're going to need to shape the copper wire. The shape has to be something that will touch the positive end or the bump of the battery and the magnet where the negative end of the battery is. I'll explain more about the positive and negative of the battery later. But for now, just know that the positive is the end with the bump and the negative is the other side. Here's an idea for your first design. A simple design, just to see if it works, is where the wire is touching the tip of the battery and then make it go around the magnet at the bottom. Now, all we have to do is to put the copper wire on the top of the battery. Make sure the copper wire is touching the bump on top of the battery and also the magnet at the bottom. Okay, that didn't work. I've got to make sure that my wire is touching the magnet enough. When the wire is touching the right bit of the battery and the magnet, it should shake or buzz. That means electricity is flowing through and you're on the right track. And then let go. Cool! Oops. It works, but I have to tweak the wire so it stays on top of the battery while it spins. Haha! There we go! If it didn't spin, here are some things you can try. First, make sure that the wire is touching the right parts of the battery magnet combo. Also, you can try flipping the magnet upside down. Maybe there is wire getting caught on the magnet somehow. If that still doesn't work, maybe the magnet is too weak. I'll explain why later. If it did spin, now we can get fancy. Try making your wire sculpture in a different shape. You can make it wider or taller or just make a design all on your own. Just make sure it still touches the top of the battery and the bottom where the magnet is. See what happens if it's in a wider shape or a narrower one. Did it go faster? Slower? Also, try flipping the magnet upside down. What happens to the spin? So, what is a homopolar motor? What is this thing we've wrought? Well, basically, it's a motor with constant electrical polarity. Lots of big words, I know. But that just means it's a machine that spins because of having the same or constant electrical polarity. So what do those mean? How does it work? Well, let's get to that. First, let's talk about the battery and electricity. The bump on this type of battery is called the positive end. You can tell by the plus sign on it. That means the other side is the negative end. You can tell that by the minus sign on it. Some batteries only have the plus sign on it. I guess the makers assumed that you'd understand if one side is the positive end, then the other must be the negative end. Nothing happens to your battery when it's by itself because it's not connected to anything. But if the positive and negative sides are connected by something like a wire, then the electricity will flow from the positive end to the negative end. That's how it powers things like TV remotes and toys. It goes out from the positive end, through the thing it's powering, and then back. So, when we connect the wire to the magnet that's connected to the bottom of the battery, the electricity flows from the positive end, through the wire, through the magnet, and then back to the negative end. Now, let's talk about magnets. All magnets have a north pole and a south pole. On some magnets, there is an N painted for the north pole and an S painted on the south. But all magnets have it even if it's not painted on. Magnets have an invisible force around them, called their magnetic field. Basically, that's the area around them where magnets always try to pull something towards them. As long as something magnetic is inside that magnetic field, the magnet will always try to pull it closer to itself. Or if that thing is bigger than the magnet will pull itself towards it. The lines of the magnetic field go from the north pole of the magnet to the south pole of the magnet. You can't see it, but if we draw the lines of the invisible magnet powers, they'd look like this. Magnets affect magnetic materials, obviously, but they also affect other things. Usually, those magnetic materials are metal things. The magnet pulls these things towards itself. That's why the magnet sticks to the battery, because it's made of metal, mostly. Some metals aren't magnetic though. Here's a quick thing you can try with your magnet. Go around your house and find the things that your magnet sticks to and the things it doesn't. Now, knowing about electricity and magnetic fields, how does the spinner work? So, we know that electricity is flowing through the wire this way. And the magnet at the bottom has its invisible magnetic field. Remember when I said that the magnetic field affects other things? One of those things is electric current. The magnetic field has an effect on the electric current. It tries to shove it in a certain direction. Since the electric current is in the wire, the magnetic field shoves that, making the whole thing spin. If the magnet is too weak, then the magnetic field will not be strong enough to shove the current that's in the wire. That means it can't make the electric current in the wire move, and so the spinner won't spin. Did you try flipping the magnet upside down? Did you notice that the spinner started going the other way? That's because the magnetic field is also upside down. So, it will shove the wire in the opposite direction. Cool, huh? Well, there you have it. That's our experiment for today. I hope you had fun. If you enjoyed this video, there are loads more like it on the channel. Look around and find something fun to do. Moms and dads, you can find us on Instagram and Facebook. Because of the made-for-kids nature of these videos, YouTube might not let you know when we have a new video up. But Instagram and Facebook always will. The links to those will be down below. Till next time, and before I go, always remember, be brave, be kind, and stay